I'm looking at question 4, although I would like to just tell you that this question was not discussed in the class, and we would be using a formula for annuities, which is like equal payments made over uh, a period of time. So this is not for the exam probably because it was not taught, but just in case you are curious to know what's happening here. The question says that assume that your parents have promised to provide you with a constant flow of spending money at a rate of $1,000 per month for next 5 years, and assume that the interest rate in the economy would be 6% per year of half percent per month. It's something like you need to pay monthly rent or cost, and you will get $1,000 each month. So each year you're going to get like a total of $12,000, or in total like $60,000 spread in equal 1,000 payment for the next 5 years. And now they have asked us to calculate the present value and the future value of this money. Just assume your parents go to a bank and say to the bank that they want to give an instrument where they want to pay 100,000 to their kid each month, and they ask the bank, what money should I deposit today so that my child can get $1,000 per month, and the bank would calculate and say that okay, deposit 50,000 and we'll pay him 1,000 each year. So because the interest, because that money would earn interest and so on. So we'll look at the present value and we'll look at the future value, because if you take a loan from the bank, what would it have costed you for $1,000 each month starting today? After 6 years, 5 years, you would have gone back to the bank and you would have paid them the money, what money you then own to the bank. So we'll look at the future value and the present value. The present value is the money that is the present value of all the payments, and the future value is again the future value of combining all the payments. In a way, the future value of all the payment is like a big money that that's equivalent to paying this thing, this 1,000 over spread of time. Okay, so what does the question say? The question says that $1,000 per month. If you just ignore the maths, just think in a commonsensical way without using any finance or any maths, it would be like 12,000 per year or 60,000 for the entire period. 60,000 for an entire period today would be a smaller money, because when you're going to discount it, it's like you have to pay some money at the end. 1,000, you can deposit some money and it will earn the interest, and that's why the present value of all this payment should be less than 60,000, although not very less. And likewise, the future value should be more than 60,000. Suppose you take a loan from the bank where you make an arrangement where you want to get $1,000, and after 5 years you go to the bank and say that how much money now I own you. Of course, that would be more than 60,000, because the bank has given you a loan to get this instrument. So even before starting, we know that we are going to get an answer like 45, 40, 50, 55 for the present value, and like 70 or 75 or 80 or 85 for the future value, something like that. We know the directions and we know which is more and which is less. We did a question in the class that involved just one cash flow, and they asked us to calculate like 10,000 today or 17,000 after 5 years if the interest rate is 10%. Or like, which one would you like to bet on? So we calculated the present value by this formula, which was 17,000 divided by 1 plus r to the power 5, and we had the continuously compounded rate, which I'm ignoring for now. Okay, coming back to the question, the first installment that you will get after 1 month, or the first cash flow from your parents you will get after 1 month, and if you want to calculate its present value, they have given us a formula. Sorry, this is 12 under 6%. So this is the present value, individual present value of all the cash flows. 1,000 after 1 month, 1,000 after 2 months, 1,000. If you look at 1,000 after 60th month is quite less. So if we can add all the values in the present value column, we would get the money that we owe. because it's the sum of present value of all the individual money that we are going to get. To find that out, we have to use a formula that comes on from geometric progression. A geometric progression is a progression where a constant r is multiplied. This is taken from Wikipedia with the first term a, and using the geometric progression we have the present value of annuity formula, which is p into 1 plus r to the power minus n by r. If I use all the numbers that are given to us, it would be 1000 into 1 plus 0.5% to the power minus 60 and divided by 0.5%. And the value as expected comes out to be like 51,725. It's less as compared to the 60,000, because if your parent can go to the bank and buy this financial instrument, pay 51,725, and the bank then would have the responsibility to give you $1,000 each month. And similarly, we have the formula for the future value. I'll quickly go to two websites to confirm if what we are doing makes sense and whether it's correct or not. First, going to a website named financialformulas.net. I put the present value, the interest rate, the number of periods, and I got 1000. So when I calculated it gave me the numbers. So this is how I calculated the annual payment. I used another website, which is calculatorsoup.com. The number of periods is 5 and interest rate is 6. The compounding per month is 12. The payment is 1000. The payment per period is 12, and I got 51725, which is exactly the same number that I got by using this formula, which is present value of annuity. And if I can use an Excel, I can calculate the sum of this column and get that. So this is how we are going to calculate the present value or the future value of equal cash flows that we want to look at. Not discussed in the class, but just wanted to talk a little bit about that in case you are curious to know this. I think we'll see this in the future. That was all from my side. Thank you for listening.